Today's notes are graphing linear equations in three variables. Solutions of equations in three variables can be pictured with a three-dimensional coordinate system. Points in the three-dimensional space can be represented by an ordered triple x, y, and z. We're going to look at the first two examples on how to plot a point. So the first thing to notice is that there are three axes. I have an x-axis, a y-axis, and a z-axis. We both also have a positive and a negative direction. So starting at 0, your ordered triple is x, y, z. So I'll start at 0, and I'm going to move 4 in a negative x direction because my x value is negative 4. So I'm going to move 1, 2, 3, 4 spaces along my negative x-axis. Then the y is positive, so notice that your y-axis kind of goes on a diagonal there. So I'm going to go over 1, 2, 3 in a positive y direction. Then I have z, which is a positive 2. Well, z is the axis that's going up and down, so I would go up 2. That point is where I plot my point. So your final answer is a single point. Let's see that again with example number 2. Starting at 0, 0, I'm going to travel 3 in a positive x direction. Then I'm going to travel 4 in a negative y direction. And then finally z is negative, and that's the one that kind of goes down at a diagonal. So we go down 1, 2 to get to my point. Please try and plot the point for example 3 and example 4 on your own. Right, the next thing we're going to do is talk about sketching a plane in a three-variable function. To do this, I first need to find the x, y, and z intercepts. To find the x-intercept, I'm going to take the equation and I'm going to plug in 0 for y and for z. So I have 4x plus 2 times y plus 0 equals 4. So I end up with 4x equals 4. Or x equals 1. This is the ordered pair 1, 0, 0, because I plugged in 0 for y and for z, and because we solved and got 1 for x. So if I was trying to plot this point, I would go over 1 in a positive x direction. This would be my x-intercept. I'm going to do the same thing and solve for my y-intercept, only this time I'm going to plug in 0 for x and for z. So I would get 2y is equal to 4, or y is equal to 2. So this would be the ordered pair 0, 2, 0, because I plugged in zeros for the x and the z. So on my y-axis, I would travel 2 in a positive direction. So this would be my y-intercept. And lastly, I need to find the z-intercept. For this one, I'm going to plug in 0 for x, and I'm going to plug in 0 for y. This one simplifies to z equals 4. So this is the ordered pair 0, 0, 4. I'm going to go up 4 in a positive z direction and plot my point. Now to turn these 3 points into a plane, you are going to connect them And you should be using straight lines. And then you're going to shade that area between the lines you just drew. This would be my plane. Let's do one more together with example 6. So I'm going to start by finding the x, y, and z intercepts. So again, I'm going to plug in 0 for x, or for y and for z. So I get 4x plus 3 times 0 plus 6 times 0 equals 12. So we get 4x equals 12, which we divide to get x equals 3. So this is the ordered pair, 3, 0, 0. Again, because I plugged in 0 for y and for z. And I'm going to plot that on my XYZ plane. Then I'm going to look at finding the y-intercept. So now I'm going to plug in 0 for x and for z. So I get 3y equals 12, or y equals 4 once we divide. So I get the ordered pair 0, 4, 0. So I'm going to go to 4 on a positive y direction. And lastly, the y-intercept, I'm going to plug in 0 for x, and I'm going to plug in 0 for y, and I'm going to solve for z. So we get 6z equals 12, which means z is going to equal 2. So I have the ordered pair 0, 0, 2. And I'm going to take all 3 of these points on my plane. I'm going to connect them, and it's going to be the shaded region in between. So this is my plane on my XYZ coordinate graph. Please try and do example 7 and example 8 on your own. Both extend slightly off the graph, so just draw in your own tick marks to help you complete the table.